Welcome back, guys.
Hello all.
So today we're going over 1617.
Yes.
All right. Well, let's dive right in. Let me share my screen. If I can find the right one.
16.
Oops. Second, 16.
Left, huh?
Oh, yeah, I have a couple left. So this one we have, I think this is the packet one, right? We're getting a bunch of packets.
Packet decoding.
Packets are coming in hexadecimal format.
That we need to convert to binary.
Convert to binary. They provide this handy little chart to do that conversion. If you need one, or you can do the binary conversion yourself. But after you get the binary, you decode the binary left to right, and each of the bits of the binary or groups of the bits of the binary encodes certain information as to what you need to do with data following it, whether the data following it is has subpackets, or whether the data following is a value, a literal. And if the data following are subpackets, there's usually an operation involved, and it tells you what operation you need to perform.
Well, that's for part two. That's for part two. For part one, we don't care about the operation.
That's good. We just need to know the version numbers, right?
Yeah.
But you do need to know how to parse to know where the borders and the limits of each of the packets are, because the version number is the first 3 bits of every packet. And so part of your logic at least needs to contain something to be able to recognize the beginning and end of each of the packets, so that you can pull out the version numbers.
Yeah.
All right.
And then, yeah, the final answer for part one is you have to sum all of the decimal values of the version numbers.
Yeah, so you add up all the version numbers in all packets. Okay.
All right.
So as an example, input, I'll show you guys my input. So that was my input.
So that's a giant hexadecimal string.
Yeah, considerably longer than the sample, but still follows the same general idea. So you take this giant hexadecimal, convert it into an even more giant
Binary.
number. So it would be 4 times longer than this.
Yeah.
And then
Parse
through it. Find the borders of all the possible packets, and then add up all the sums of the version numbers from each of the packets.
Yeah.
All right. So who wants to start today's?
I can start for part one. Part one was much easier than part two on this one for me. Let me get to it. Code. All right, here we go. Day 16. I have quite a few different sample files that I was testing against. But let's get started with my actual code. Can you see it? Is it big enough? Larger would be okay?
You can see it.
All right then. All right, so I do what I always do. I import my file. This one, instead of calling it input, I called it binary. Even though that's a lie, because when I'm importing it, it's currently not binary. It's currently hexadecimal. And then in order to convert to binary, I actually used that binary map that they gave us in the question, because I was running into some problems when I tried to do JavaScript's built-in conversion to binary. Some things were getting lost or cut off. Mostly
Zero, the last zero.
Leading zeros.
Yeah, leading zeros were getting cut off. And even then I had some weird issues where if it was super long, some things would not convert correctly. Or at least with some of the examples I was trying, I was having issues. So for consistency's sake, I ended up doing it myself. So I used a binary map here, and then I created an array with all the different hexadecimal values that are possible. And then I did my favorite thing. I used a for each loop of the regex in order to replace all of the regex values, so the hexadecimal values, with their corresponding binary representation. Okay, so now since I replaced my original string, now my binary name fits where now it actually is a binary. At the beginning it was hex, now I have a binary string. So now I can do with it what I want. So the first thing I'm going to do here is I created an array to store all of the version numbers. So I'm not going to add them as I go. I'm just going to store them and then add them all at the end. So this is just going to be an array of strings for my version numbers. And now the meat of my code here is, of course, I like to create constant C for my length. And I'm consistent with that though. It's always C for my length. And then I'm going to loop through my string. So I'm going to loop through my binary string. And I got a few weird things going on here. So let me try to explain well. So I'm starting at 0. I'm going until the end of my string. And I left out my accumulator here, or my, I don't have my I++ like I normally would in a for loop, because I'm going to handle that within my loop. So now the first thing I want to do is I'm checking if we're at the end of my string pretty much. So I'm checking if my binary, if everything from this point on in my string has ones. Because if it has ones, then it's still going to be important. It's still going to be things that I need to check. If there's no ones, then that's going to be the extra zeros that are left over from the hexadecimal conversion. So that means I'm finished. I can break. So now I'm going to get my version number. So to get my version number, I'm going to get the substring of the current index to the current index plus 3. So I'm going to get those 3 bits from where I'm starting until 3 later. It's going to get the 3 bits. I'm going to push that into my versions array. I'm going to deal with it later. Right now, I just want to continue parsing. So that's going to happen for every packet that I come across. I'm going to push the version number. Next, I'm going to check what type of packet it is. So the next 3 bits are the T, or the type, I think it was, they called it in the problem. So I'm going to get my substring from I+3, the current index plus 3, to the current index plus 6. So that's going to give me the 3 bits right after the version number. So this will represent the type of packet. And now we have 2 types of packets. If I take the decimal value of my T value, so in JavaScript, I'm using % of T with base 2 to give me the decimal value from a binary. I'm going to check if that's equal to 4. So if that decimal value is 4, then that means it's a literal value packet. So I have to do something different with that than if it's an operator packet. So if it is a literal value packet, then the length can vary. It can be a minimum of, I think, 11 bits long to a maximum of infinity, really. So the way to check that is to check for the first bit in the group of 5. So it'll have 1 bit, it's either 1 or a 0. If it's a 1, it tells you that's not the last one. If it's a 0, it tells you that that's the last one. And then it's going to be followed by 4 bits that will actually be the value. So for here, I'm creating a J variable that's going to be my current index. So the index of the start of this literal value. So minus the V and minus the T. Now we're going to start at the next index. And I'm going to check if that index in my binary string is a 0, or sorry, if it's not a 0, then I'm going to increase my J by 5 because, okay, we're not at the end yet. My J needs to get 5 bigger, and check the next 5th value to see if that's a 0. If that's not a 0, we're going to keep checking until we get to the 0. And then, so my J is just going to keep growing until we get to the last kind of sub packet inside of this literal value packet. And now I'm going to add that to my I, because I'm going to use my I as my counter or my placeholder to tell where I'm going to start on my next loop. And so now I'm going to continue. So that means the next loop is going to start at the beginning of the next packet. I found the total length of this packet, and I've added that to I. So that when my loop restarts, it'll be at the very first bit in the next packet. If that's a literal value. If I have an operator packet, the length is a little bit different. It was actually easier for operator packets here because operator packets have 1 extra bit after the first 6. So the first 3 were the version, the next 3 were the type, and then the 7th bit in an operator packet tells you the length of the next part. And so if that next value, I forget what they called it. I think they called it the I value for an operator packet. If the I value is 0, that means the next 22 bits will tell you however many packets are inside of that sub
Oh, it was,
packet. Or the length, was it the length?
wasn't it 11 or 15?
That was the last section, the while loop that we just finished up in 51.
Yeah.
Okay.
So, yeah,
Sorry.
so, yeah, I think you're right. It was either 11 or 15. And so I'm adding that 11 or 15 to my total length. To get the total length of this operator packet will be 22 bits. Whereas if I is not 0, if I is 1, I mean the big I, so like the length indicator of the operator packet. If that's a 1, then the total length of this operator packet will be 18. So I'm going to add that to my index that I'm searching. And then, yeah, I'm going to continue on to the next loop. So the next loop will start at the beginning of the next packet. So I'm pretty much skipping everything in between and just going packet to packet, just collecting all of the version numbers. Very shoot myself in the foot because part 2 is going to be a lot harder because I ignored half the question, but it got part 1 done. So then all I need to do is just sum the versions that I have in my versions array. So I'm just going to use a reduce function. And I'm going to parse int with base of 2 for all of the values in my versions array. And then log my sum. Not too hard for part 1. I skipped most of the important things. That's going to come back to me. It made my part 2 a little bit more difficult. But yeah, any questions on this one?
Nope, pretty good.
All right.
Kirk, you want to go next?
You want to go next?
Would you like to go next?
Can you go next?
Oh, you want me to go next? All right. Let's see, share mine.
Burnt my tongue earlier. This
16.
lid keeps it too hot.
Okay, so I have my typical thing where I start out with hard-coded inputs for demo purposes, and then the file later on. I also found a online conversion thing on Stack Exchange to convert from binary to hex, but I looked at it and I don't know why, but I chose not to use it. But I thought there should have been one that's already existing, so I found one. I was like, oh, there it is. But then I was like, yeah, might as well just use the one that came with it. So I created my own 2-binary function. Other than that, there's my data structure that just basically takes all my input, converts it to the binary text value equivalent, and pulls it all back together into a string. So now I just have a giant string of binary zeros and ones. Okay. Other than that, I have one giant function that does a lot of processing for me, called process packet. And let's see, do I call that recursively? No, I just call it, oh no, I do call it recursively. So this function essentially just follows the directions that, as they were listed. The only things that really to note, I pull out the version string from the first 3 of the string that's coming in, convert that to a regular decimal number, add it to my total, which I'm just accumulating over time because this is a recursive function. And then I get the type string and a type number from the next characters of the packet from positions 3 to 6, and then convert that to a number to get an idea of what type number it is. If it's a type number 4, I do something. If it's not a type number 4, I do something else. It's type number 4. These are literals, and the literals they have in the instructions they give you now how to define how to find out how large literal is, which is dependent on the first bit of the stuff that's coming in of 5. So you get them in chunks of 5s. If it starts with a 1, I
It keeps
believe
going.
it keeps going, and if it starts with a 0, then it's the last group of literal numbers to pull out, and so it just looks for this to stop being a 1. The starting bit of each of the block of 5, it waits for the starting bit of the block of 5 to be not 1. But if it is a 1, just translates the 1, and keeps going. Yeah, looks like I'm just reconstructing and just keeps going until it finds the end of it. If it is not a literal, so it's a
Operator.
an operator, I pulled a length type out of it, which should have been a single bit, either a 1 or a 0. And depending on the length bit, then I pull out whether it needs to be linked by actual literal length, like they actually tell you how long exactly it is in a length packet, in a packet length string, which is bits 7 to 22. Just turn that into a hexadecimal number, pull out those, and look inside those to see whether or not I need to process additionally. So when I pull out the sub packet, instead of just listing as a sub packet, I call process packet again to see are there sub packets inside those packets, and so it just unravels as long as there are sub packets inside sub packets inside sub packets, just keeps calling itself until it unravels all the sub packets. I think there's only one level of sub packet though, so I'm not really sure how much of a benefit that ended up being. But anyways,
What do you mean, one level of subpacket?
so if there is an operator, and inside the operator there's subpackets, is there an operator inside the subpackets? If there's an operator inside the subpackets, is there an operator inside the subpackets?
Oh, yeah.
Oh, I don't know.
Mine was nested at one point like 15 packets deep. So I had operators inside of operators inside of operators.
Oh, okay.
So it gets deep.
Well, that's what this is trying to address. So I don't have to reprocess,
That's nice.
trying to get
Just
the
recursion.
heads and whatnot. And then essentially, as it's processing all these sub ones, it's basically just ripping out all the versions, putting them into total, and then because it's a reference to a total, every sub recursion is all editing the same number. So the same number just keeps getting edited, as well as the string. So it consumes the string and updates the number with every recursion, because everything is done through references. And then if it's a subpacket of length type 1, then this is one, I believe where you,
Is it the big count?
yeah, it's the one, no, it's the one with the subpacket counts. You have to, it tells you how many
Ones are
subpackets there are. And so I go through and try to find the number of subpackets. Yeah, as long as there are ones in them, as long as it's not the end of like a literal.
Subpackets.
Yeah, and then I just call process packets again, and it'll open up that packet to see how many packets there are. As long as it keeps opening up sub packets, it increases the iterator to make sure the iterator stays within that sub packet number. So if it says there's only 3 sub packets after 3 iterations through this, then it says, okay, that's enough, and it keeps going.
Very nice.
So it processes all the sub packets. So that's it. So it's just a recursive function that just make sure that it's not a literal or an operator, and if there are subpackets within the operators, it recursively calls itself to take apart those subpackets.
Your explanation was so simple. But
Yeah. It's pretty much essentially what the instructions, I try to follow as closely as possible what the instructions were asking.
Okay.
Yeah, and at the end, I should get, again, because I have passing a mutable reference, the total should be updated by all the recursive functions and then returned within that same variable that I gave a reference to. And then I should be able to just call that thing and see what it is, what state it is in now that all the recursive functions have operated on it.
It seems like part 2 is going to be really easy for you because you set everything up nicely in part 1.
It was easier. Yeah, I think so. But I don't know.
It will still work.
Yeah, it's always still a little bit of work. Any questions?
No.
No. So mine was pretty much, I take that string and then I'm doing, for the large part, I'm just ripping out indexes out of that string, right? So very specific spots out of that string for almost all of it. And so taking positions from 3 to 6 non-inclusive, positions 7 to 22 non-inclusive, start +1, start +5. These are all string positions. So it's a lot of just popping around the string, just popping around the string, getting values out of the string, and then
checking,
yeah,
skipping things that don't matter.
skipping things that don't matter. I have a string called new string, which I clone, I believe, at the beginning. Maybe I don't. Where's new string created?
I did see a
Oh, there it
column
is.
somewhere.
So before I call the sub packets, I clone it so that the sub packets, when they start manipulating their strings, they're not. Oh no, but the odd thing is I could probably have saved myself a return and consider this a mutable reference. In other words, I could have just had the sub packets change this one, but I'm not sure what that would have done with. But that would have worked too. I think that would have worked as well. Because everything is being consumed from one side of the string, and we're not like consuming pieces of the string, so then you don't have to like have holes in your data structure. As long as you're consuming from one side of your data structure, just consuming as you go consistently, then I could have just passed a mutable reference instead of a reference, where every sub recursion is just consuming more and more of the string, as well as tallying the subtotals and just passing back the reference after it's all done. Oh. Yeah, who knows? But that was my approach. Just process the string from left to right, eating up that string, figuring out what to do, and passing it back to itself if it needs to, see whether or not, again, is it a literal, is it a sub operator? And if it's an operator, then pass it back up. Is it a literal, is it an operator, and so on and so forth down the line. All right.
Cool.
Okay. Python.
Yeah.
Let's do it.
Okay. So this is my part 1. I am starting right around here. Okay, so I also have my custom decimal to binary function, because when I used the built-in method to convert decimal to binary, it was missing the leading zeros. So it was skipping the zeros at the end. So in my custom decimal to binary, I'm adding leading zeros. If they are, if the initial index item is 0, I'm adding 4. If it's 1, 3 leading zeros, 2 or 3, 2 leading zeros, otherwise 1, and etc. So after I get my binary string, I'm passing it to my bits transmission function. I'm passing my binary and a length of this string. I'm passing the length because this is a, later on I'm using it as a recursive function. So as I move forward, I am determining the length of the packet I'm working with and passing it to my bits transmission function together with the binary. So first I will get my packet version and remove it from my binary string and append my version ID to my version ID's array, which is a global variable. And next I'll get my type ID from this binary and also remove that chunk from my binary. And I will decrement my length, initial length, because I have I have cut 6 elements from my binary so far. So if it's a literal packet, I will calculate the literal value and return my binary. I will just, for now, I will just print the literal value since we do not have to work with it. I'm not keeping track of it. And if it's not, if it's not literal packet, it can be both. It could be both. Like it could be the next, which is the length step ID, could be 0 or 1, and that can determine which one of the subpackets it could be. If it's 0, I will get my length step ID, which will be the first element. That's a 0 index. And after I get my length step ID, if it's 0, next 15 elements will determine the length of the subpackets for this packet. So I will get my 15 binaries and cut it from my binary. And after that, I have a for loop which will go until my total length in bits, and it will have steps of 11. So every subpacket will be 11 bits except the last one. It could be more than 11. So as I go, I will chunk my binary and call my recursive function with the same binary and different lengths. This will be the length of the current subpacket. So if it's 11, it will be 11, otherwise it will be more, it might be more than 11. So every time I call my bits transmission, it has to return a binary, remaining binary, after calculating or decoding this binary which I passed. It will return the remaining binaries. So I'll reassign it to itself and go on my loop. And next one is, it could be 1, which means next 11 binaries will determine the length, number of subpackets. So I'll get my number of subpackets and remove the 11 bits, which is used to determine the number of subpackets. And I have a for loop here too. So yeah, if length binary means if I have a chunk which has a length less than 11, which means I'm on the end of my subpacket, probably. So in that case, I'll break. Otherwise, I will keep calling my same function with the binary and length of 11 bits. At the end, I will return my binary. Yeah, this is part 1 for me.
Sure.
No questions?
Good job.
Okay.
All right.
Did you do it last night?
Yeah.
Good job.
All right, let's move on to part B. Now, part B, now we actually have to do the sub packets. Well, we have to do the operations, right? And they give us other types along with the operations. And
Did you want to share your screen?
yeah, I guess so. Second.
Yeah, so every operator packet now, we need to actually inspect the type bits to see what type it is. So before we were only caring if it's type 4, and we knew type 4 was literal packets, literal value, and everything else was a generic operator packet. Now the type matters. Now we actually care about what type of operator packet it is. So if it was type ID 0, that's a sum packet where it'll sum all of the sub packets, and there can be any number of sub packets inside. Type 1 was product packet, which is the same thing, except we're going to multiply all of the packets inside. Type 2 is minimum, where we could have a number of subpackets inside, and we're going to take the smallest value of those and only return that smallest value. Type 3 was maximum, which is the same thing, except we'll take the maximum value of all the subpackets. Type 5 was greater than, and type 5, 6, and 7, greater than, less than, and equal to, will only always have 2 subpackets. And we have to return the one subpacket that, or sorry, if the first subpacket is greater than the second subpacket, the value is going to be 1, or else the value is going to be 0. Likewise, with the less than packet, if the first value is less than the second value, then it's going to, the total value will be 1 or 0. And with the equal to packet, if the total, or sorry, if the first value equals, so is the exact same as the second value, then the total value is going to be 1. If it's not equal, it's going to be 0.
Basically true, false.
Yeah, so now we're
It's
gonna,
true, it's 1,
yeah.
false is 0.
So now at the end of this, we'll have this giant, it'll essentially make a giant equation that we have to evaluate. We have to evaluate all of these operator packets with the literal value packets and find out what the final value is.
Yeah.
All right.
So you want to start this one, Python, Farouk?
My it's not completed. I'm on the process, like I managed to get all the signs, like is it product, maximum, mean, and also which means type ID. I managed to get type ID and as well the value.
Okay.
But yeah, I'm having trouble in generating that giant equation which got described. Like I have type IDs, maximum, greater than, less, and equal to, which exactly need to have 2 subpackets. But in my sequence, sometimes I have only one type ID 5 or type ID 6, and I'm assuming it's because their inner subpackets needs to be calculated to get another pair of this.
Yeah, they probably, they also have subpackets inside that are not just literal values.
I need some more work there.
I can show you my final equation at the end. I don't know if you guys ever, I don't know if your code allowed you to see your final equation, but I can show you what mine ended up looking like. It was a giant, giant mess with tons of nested packets.
All right, let's see yours.
All right, I'll show mine then. So this is one where I'm not sure whether to be proud or completely embarrassed of my code. I don't know if I'm an idiot or a genius, probably idiot. So
What's the difference?
let's see. All right, my part 2. Can you see it? Can you see my file here?
I see the screen for admin and code.
That's not what I wanted to share.
Okay.
Let me share something else. All right, now you see my code, yeah?
Yeah.
All right, so I'll try to go quick because it's a lot of code. I think I have like 160 lines, but a lot of it's comments too, to help me explain it. So at the beginning, it's the exact same as my part 1, just converting to binary. All right, now my first new thing here is I'm gonna initialize a stack. And I'm going to use this to track the unfinished packets. So packets that have opened up but have not closed yet. Next, I created an array with all of the different kinds of actions corresponding to their type value. So type 1, I'm going to put it here is a sum packet. Type 2 is a multiplication, a product packet. Type 3 and 4, I'll get to a little bit later. Or sorry, that was, yeah, type 0, 1, 2, 3. Type 4 was a literal value packet. And then we had greater than, less than, and equal to. And this looks confusing. Why did I do this? Let me explain. So my whole thing depends on a string. I'm going to add everything into a giant string equation.
Are you going to evaluate the string?
And I'm going to use math.eval on my string.
Wow, okay.
Because yeah, eval in JavaScript works okay with strings. So I can just evaluate the giant string as a math equation. So this was my process. It's the dumbest thing I've ever thought of, but for me, it was the easiest way to go about this. And yeah,
All right.
so here we go. So we're gonna, again, I'm gonna capture my binary length, so the entire length of my binary array. or my binary string, and then I'm gonna loop through everything. All right, so now I'm initializing a couple things here. I'm gonna initialize current. I'll get to that later. That's gonna be the current packet that I'm currently inside of. And next I have a little while loop. So I'm gonna use this while loop to check if my current packet or the most recent packet in the stack has finished, if it can close. So I'm going to start out with packet complete is true because I want this to run at least one time. I could have done a do while loop, but we're going to set packet complete is true, and I'm going to loop through here. So now I'm going to check I'm going to get my current packet. So that's going to be the last packet that's been entered into my stack. Now, if that packet is already in process, so that means it's going to have a length that's greater than 0 and a bit count greater than 0. Let me show you that. So each element that gets added into my stack is going to have 4 properties. I'm going to capture the target length. So if it has a bit length target, then I'm going to capture how many bits does that packet have to be. I'm also going to keep the action, so plus, multiply, whatever, and the bit count. So this is going to be the current count, how many bits are currently in that packet, so that I can tell when it's finished. And I'm going to keep track of the amount of subpackets that are currently in that packet. And my target length here is a dual purpose one, actually. Target length, sometimes this will include the target bit count, and sometimes it will include the target packet count. Okay, so this one ended up being dual purpose, which worked out fine. Luckily, I didn't have any overlaps, which I could have. All right, so let me continue. I'm going to check that now that current is, again, relating to the last packet in my stack, the most recent open packet. I'm going to check if the length of that packet is equal to the bit count. Sorry, if the length is greater than 0 and the bit count is greater than 0, that means I'm currently working on it. I'm currently adding things to this packet. So now I'm going to check if the target length is equal to either the current bit count, so how many bits inside of it is equal to the number of bits I want, or if the number of subpackets inside of it is equal to the target length. Remember, target length is dual purpose. It can hold either the number of required subpackets or the number of required bits. So if either of these is true, then I'm going to continue with, then that means that this packet is now finished. It can close because it has everything it needs inside of it. So now I have a few conditional things to check depending on what type of packet it is. So if my packet type is a greater than, less than, or equals to packet, well, like Alex mentioned earlier, these are essentially true or false packets. So I'm going to add in a ternary operator to my string. So I'm going to keep my string. I'm going to reset my string to what I have so far in the string, and I'm going to concatenate to the end of it a ternary that just has a question mark, 1 or 0. Remember, I'm working with a giant string to evaluate everything. If it's not one of these 3 types of packets, then all I need to do is add in, then my string can close. So the only thing I'm adding here is just a closing round bracket. So that means that packet's going to be closed. Then, since that packet is finished, I'm going to pop it off of my stack. And I'm not resetting my packet complete here because now I want to keep checking. I want my while loop to go again and see if the next packet in my stack is now finished also. Because maybe multiple packets will finish at the same time. Maybe I finally add in the last packet that one other packet needed, and maybe that closes a lot of them sequentially. All right, well, if either of those if my conditions are not met, then that means that the current packet is not finished. It needs more things added to it. So then I'm going to continue. So now let me go on. So what I'm doing here is I'm going to check. So this is an end check. So if I'm at the end of my string, my binary string, and there's no more ones, that means I'm finished. There's just zeros left, which is just junk that I can ignore. So that means we're going to break out of my loop. I'm done. Next, similar to my part one, I'm going to get the T value, so the type of packet. I have deleted the V value now because I don't care about it. I'm not going to even consider the version numbers anymore. Now let me check my T values. If my T value ends up in decimal form being a 4, that means it's a literal value. So similar to my part one code, I'm then going to parse through that and see to make sure I'm not at the end. And I'm going to store so remember we had chunks of 5 bits. The first bit was, the sole purpose was to let you know if you're finished, to let you know if that's the last chunk of 5. If it's 0, that's the last one. If it's 1, you have more chunks to examine. So I'm going to add all those into my literal value variable that I'm storing here. So I'm going to add all of those chunks. So not the first bit in each 5 chunk, but the next 4. You follow? Is anyone listening? Everyone's lost already. So now pretty much I'm just going to go through the rest. Now, because my packet is getting longer, so I've added more bits, I'm going to increase the bit count for every packet in my stack. Every packet in my stack has just added things to it, or they will add things to it. So I'm going to increase my bit count by that much, by the length of the current packet. And I'm going to add in this. I'm going to increase the sub packet count for my current packet in my stack, because only the current packet will now have an extra sub packet inside of it. It doesn't count as a sub packet for the outer packets. So now what am I doing here? I have an extra conditional here to check the type of packet. If it's a maximum packet, a minimum packet, or an equality packet, I need to do something a little special. I don't need to add in an action. So I'm just going to concatenate my string with the literal value converted to decimal. But if it's not a max, min, or equality packet, that means it's a sum or a product or greater than or equal to, then I need to concatenate my string with my current action. And again, that current action is going to be one of these values. I'm going to concatenate it with the string, the current action, and then the literal value. Okay. All right, so that's only for literal values. Now, actually, my operator ones aren't that tricky. Let's go on. So for my operator packet, I know, okay, this is an operator packet. The first thing I'm going to do is I'm going to catch the action. So I'm going to check the type, and I'm going to get the action based on that type from my actions array that I've shown too many times already. Next, I'm going to get that I value. That this large I was that 0 or 1 that tells you the length of the next part and what it's going to tell you, if it needs subpackets or bit count. So now I'm going to check here if my if my operator packet is of type 2, that means it's a minimum packet. I need to get the minimum value. So for this kind, I'm going to add to my string. I'm going to add the current string plus the current action. And for this one, that action was, I believe, okay, so this current action is my action from my previous packet that I'm currently inspecting, that I'm currently inside of. I'm going to add in my new action will be math.min, and then I'm going to open up a new packet. So I'm going to do that same kind of process if it's math.min or math.max or equals. Equals, I don't need anything special. Is it equals? Let me check. Yeah, so this one's going to be an equality packet. All I need to do is just open up the packet. And I'm going to have my checks later. So it's very confusing, I know. I was so confused doing this one, but let me continue. Now I'm going to check. If my stack, the length is greater than 0. So if my stack is growing, if I have things inside of it, and my stack is not empty, or I'm not at the end of my stack, what am I doing? Whoa. Okay, sorry. If my current, so if I have something in my stack, and then I'm going to take my last value in my stack and add to its subpackets because I'm adding a new subpacket. Next, I need to add to my bit count. So I need to increase the bit count for all of the subpackets that I have in my stack. So I'm going to check the type of operator packet. If that I value was a 1 or a 0, I'm going to get the length of this operator packet. If the I value was a 1, then my length is going to be 18 bits for this operator packet. If it's a 0, it's going to be 22 bits. So then I'm going to increase the bit count for all of my packets in my stack by that number, by that adding either 18 or 22. And then I'm going to add my new operator packet to the stack. So I'm going to do stack.push with my target length. And my target length here is going to be the value of whatever came after that I value. So the bits in the operator packet that tell you the length, that tell you either how many subpackets will be inside or how many bits will be inside. I don't care what type it is right now. I'm just going to add it to my target length. I'm going to add in my action, and in my bit count, I'm going to initialize to 0 because it's a new packet, a new subpacket opening up. So it currently has nothing inside of it. It doesn't have any bits inside. It doesn't have any subpackets inside. And then I'm going to skip ahead to the beginning of my next packet. So I'm going to increase my counter, my I, to get me to the beginning of my next packet.
Yeah, I think if you, because you have it in two halves, right? You have the literal and you have the operator.
Yeah.
I think if we started with the operator, it would have made more sense because you start your string in the operator section. Because when you were looking to the literal section, you had the close bracket because you were working on the numbers now. I'm like, where's the open bracket? And it didn't happen until the second end, and then it all kind of made sense because you actually create the string from the operator and then finish the string with the literals. That's how our, we can't have the number just like 2
by
and
itself.
3, right?
No,
We
no,
have to
no.
have 2 plus 3. So we
Yeah.
need an operator. So everything actually starts with the operator saying that, oh, a plus operation happening. Here's the operands 2 and 3. And so that for me, it didn't make sense until the second half. And I was like, oh,
Okay,
okay,
so
now
let
it
me-
makes sense.
Okay, so essentially my actions were like the things that I'm placing between all of the operands inside of a subpacket.
Right.
That's why for min and max, I had commas,
Yeah,
because
yeah.
I want to comma separate all of the values inside of there. And so now actually the cool thing about mine is I could see my final equation.
Mm.
I have that printed right here. Let me uncomment it so you can actually see this giant thing. And I'm going to scroll over so you can see the fun part. So yeah, 2,556 plus math plus max of this plus this. And I was lucky. I was so happy. I tested actually to make sure that the eval function could deal with ternaries. That was my one thing I wasn't sure of. So I tested that right at the beginning before I even went any farther with this method, because that would have ruined everything.
That would be really-
Luckily it does.
Same with the math.
So I have a giant string equation here. It's huge, but the interesting part to me is a little bit farther. Let me keep showing. So we get to one point where it just gets crazy. Not quite there yet. Here, look at this. Okay. Math.max of the subpacket, math.min, math.min, math.max, 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 math.min. Look at all these nested packets.
I think that's what
We are so
that's what-
deep inside here.
And there's only one number.
Yeah.
Inside that entire nested max min, there's only one
There's a
number.
single literal value inside of it. It is
So-
just subpackets with emptiness inside.
Yeah.
I thought that was hilarious. Like, I know that the creator of this puzzle did this to catch people's code, I think, because if people only like searched a few packets deep, it would have failed right here, because here it gets really deep.
Yeah.
So I thought that was pretty tricky of him, but I also thought it was nice that I was able to see it.
Yeah. I
And
like
also-
the rainbow
and
effect on
also-
the parentheses.
Yeah.
And also it's written that this min and max stuff are supposed to have only 2 subpackets, like exactly 2 subpackets.
Oh, that's true. Yeah.
That's also
Yeah.
catchy here, because now we are going like nested, but at the same time, you are going deeper and it's more than 2 subpackets inside. Seems like it.
Well, not technically, because each one, it'll have subpackets inside of its subpackets, but those don't count as subpackets for the parent. Like, for example, if I'm the parent and I have two subpackets inside of me, those two subpackets are my children. Those children can each have their own subpackets, which don't count as my subpackets. I would still only technically have two children, but my children can have children. So I maybe have grandchildren, but they're not my children. So technically it's still only two subpackets. But yeah, I find it weird. I thought that, yeah, min and max were supposed to have two subpackets, but it looks here like they only have one for a lot of these.
Well, the
Some of
outer
them.
ones, the max or the min might be
Yeah.
the other one, but that inner 58674 surrounded by at least 5 parentheses. Seems like that's the only operand.
That was a weird one.
Huh, interesting.
Don't know what
Yeah,
happened there.
right. So if you get the minimum of 58,674, which will be itself, and mass min, you will run it on only one digit, right? On one integer.
Yeah, so it'll pretty much return itself. Right?
But it has mentioned.
Yeah,
the
okay, because
min-
yeah, max and min don't need to only have two subpackets. They can have any number of subpackets. Greater than and less than have to have two subpackets.
Right.
Hmm.
But max and min can have any number. So yeah, the minimum of, well,
Min can have
The-
like
the
13
minimum of-
subpackets. and
the
you'll just
minimum
return the
of
last one.
58,674 is 58,674. The max is the same thing.
Right. Yeah, it's just
So it's pretty
Can
much
you
just
see-
nesting it to make it more complicated, when really you only care about that one value. And I think at
Can
the
you
end of
see-
here, we actually end up, a lot of our values cancel out because we have a lot of places where we do greater than or less than, and the value just goes to 0.
Mm.
And then it's like this giant number multiplied by 0.
right.
So a lot of this entire equation gets canceled.
Hmm.
Anyways, that's my giant mess of an answer for day 16 that I was happy to be finished with.
Cool.
All right. Let's see a more logical way to go through that.
It's more logical, but I'll show you my rest. Which pretty much builds upon my part 1. So since I had a lot of the logic already built for part 1 in terms of the way it, so since I used recursion to operate on all my packets, and every time it encounters a packet, it just tosses it back itself to reevaluate this new packet. So this is why it's called process packet, because I found a new packet. What am I going to do? I'm going to process the packet. Find a subpacket. What am I going to do? I'm going to process the packet. So process the packet. The stuff that I added on this one, I think, is here. Well, there's a little bit more, but this is the a main one. So I added a function called operation, and an operation takes an operand and a type number, and depending on the operand and type number, it executes whatever it needs to do. So if it's a plus, it does a plus. If it's a multiply, it does a multiply. Just using a fold to do those. Min max, just use the min max functions on whatever operands came in. And then the greater than, less than, or equal to is just a if else case that brings back a number. So try to keep it somewhat simple. And as it goes through these sub packets, depending on what length type it is, essentially if it encounters one of these operations, let's see, it should store the operation. So it'll gather up all the subpackets. Essentially what you're going to do is you're going to have operands of operands of operands, like what you'd had, and then eventually you're going to end up with literals, right? And so when you eventually end up with literals, oh, I'm going to get these 2 literals. What do I do with these literals? And then that's when the operation comes in. Oh, there was an operation. The operation was depending on the number that I got, right? The type number that I picked up from up here, from the 3 to 6 bit, the 3rd to 6th bit, right? It's that number is a 1, 2, 3, 4, or other than 4, right? depending on that number, I'll do a plus minus divide or whatever. And so it'll just hand that off to operation and say, hey, you figure out what to do. And operation will be like, oh, it's a plus, and then takes these two literals and adds them together. Oh, it's a multiply. Take these two literals and multiply them together. And then I'm finished with my sub packet. So then it calls its parents, and its parents might be another sub packet that needed to combine a bunch of things with a bunch of operation that was waiting for all its children to come back with a finite number. And then when its children come back with a finite number, be it from a literal or a sub operation, right? Because the sub operation will either return an addition, which is a number, a multiplication, or return a number. Min, max returns numbers, equals, less than, greater than, they all return numbers. I get these bunch of numbers. What I do with all these numbers, I look at my operation to the type number. What was my type number? And then if it's multiplied, then I take all these children and I multiply them together. If it's add, I take all the children and add them together. So that's essentially the thought process on that. So it doesn't change, fortunately, too much, but I did have to add in, what do I do with these children? And I hand that off to an inner function. Was it?
When I first encountered this problem, recursion never even occurred to me as a way to solve it. But now that I see your code and your explanation, it makes so much sense.
Yeah. Well, but you know, it's also just thinking about it for a while. So,
Yeah.
but that was my solution. My solution was recursive, and because it was recursive, it simplified some of the handling. Because every, you know, think about it this way: I'm a parent, you're a child. At some point, you're going to be a parent, and you're going to have children. At some point, those children are going to have children. We're all going to be doing the same thing. It's just, you know, a matter of, you know, rolling it out downwards and then getting all the numbers and rolling them back all the way up to the parents. So it was pretty, for me at least, a pretty natural fit for recursion. But yeah, the only tricky thing is, you know, when do you pass by value? When do you pass by reference? I mean, yeah, I said at the beginning of this entire series, don't do pre-optimization, but the whole time I'd be like, oh, I have references now, I have pointers now, like something I didn't really have for the last decade or so, programming with interpreted languages. I'm like, oh yeah, it's pass around as many references as possible to keep it, you know, memory efficient. It gets, yeah. Then you get like, I can't cast this because it's a reference of a reference. Like, oh shoot, can I get the owned? And then if I get the owned, then then I'll just get the owned value. I'll own the value, but then now I can't use it again somewhere else because it's already been moved. And so it's out of scope. It's got all these weird, interesting memory implications. I appreciate what it's doing because it essentially makes my program memory safe, but at the same time, it's trying to pre-optimize early on. It really bites you in the ass with Rust. And I'm not sure if, you know, as I get a better Rust program, I'm sure a lot of things will start becoming a little bit more natural as to when to choose to pass by reference and when to choose to pass by value. And I noticed when I was looking through, like, even the Dijkstra code that we were looking through for, and when, you know, how they chose to go and create a struct. And above the struct, you'll see that they have some compiler notes or directives saying like copy and clone, which means that what happens is that when this struct that you create, I think they used edges and they use state as the two structs. As those get passed by parameter, because they have those directives, they actually get copied in memory. And so, and I would be like, those should be passed by reference, so you can save memory. But I'm like, that's a pre-optimization, and you know, I already went down that rabbit hole. Now I realize, no, let's just worry about that after we get this thing working, and then we can optimize memory usage. But anyway, that's the tricky thing here. So even the operations, for example, I pass on a reference to the operand instead of the operand itself. Which really, I don't think really matters that much because they're just numbers. It's a vector of numbers. I don't think it's really that big of a difference. Anyway, that's an aside.
Should probably get on to 17. It's already been
Let's
an hour.
17. Let's do it. Sorry for rambling. All right. Let's read 17. Trick shot. So this is a ballistic simulation where you have gravity and at least some constant of resistance, of air resistance acting upon your trajectory to have a certain parabolic path to your projectile, right? And they actually give you the rate of decay on each of these, right? For every, due to drag, the probe's x velocity changes by
Horizontal
1,
velocity.
right? So the air resistance works pretty strongly. It's like, by 1 every time.
So it
goes
gets
forward.
slower every step
Yeah,
until it gets to 0. And then once it's at 0, it doesn't change.
yeah, it doesn't change. It's just basically it just falls.
Yeah.
You don't have any more x, you just have y. But the y, due to gravity, the y also decreases by 1. So a very simplistic model, but
But
fairly effective.
y continues to decrease by 1 even after.
Yeah, until it hits
So
something,
it'll-
right?
Yeah, well,
But it never hits anything.
it'll initially probably be going up, and then it'll go. The y acceleration will go down to 0,
Right.
and then it'll accelerate downwards until
Oh, that's true. Yeah, yeah.
it'll
When it
keep
goes
going
up,
faster downwards.
Right. So just acting out just like gravity does, right?
Yeah.
It's a constant force until it hits something.
Yeah.
Interestingly, our target is not a solid thing. It'll just fly right through the target. And we're getting snapshots of where that target is, where that projectile is. And on one of these specific snapshots, it has to be within a certain area.
And that's what our puzzle input is, I believe. It's just the target area.
Yeah, it's the target area. So will any of your snapshots of time produce a picture where your projectile will be right within that particular plane?
All right. And for part 1, we had to not just figure out how to get into the target area. We had to figure out how can we get into that target area with the maximum velocity or the maximum y position.
Yeah, the
We want to
high-
shoot this probe as high
as it
as
can
we
go.
can and land in the target area.
Right.
So we had to figure out maximum y.
Yeah.
Go.
Okay.
You want to go first, Berg?
Okay. Okay, so I have one function here. I use the same function for both problems. So I have a shoot probe and I'm passing my input as a string here. And inside my shoot probe, I'm first trying to get my X range and Y range as an array of integers. So it will have 2 elements, 0 index and first index. And 0 index will mean the starting and 1 index means the ending of the target area. So my X range and Y range will be 2 different arrays containing the starting and ending points of my input. So yeah, basically string manipulation and getting my numbers. So I'm starting here. Since in the first part, we have to consider only the highest, we have to find the highest height we can reach. I'm starting with 1 height. So I'm not considering the negative directions because it has to go higher, right? So I'm starting to go up from 1 until 100. Yeah, ignoring the negative directions. So I have my velocities. This will be the list of the velocities that will make my probe land on the target area. And I have a maximum y height. It will be the height which will, one of the velocities will make the probe reach. So I have my for loop for my y direction and I have for loop for my x direction. And first I'll get my velocities, which will be the x and y on these temporary variables. So, and I also determine my initial points because every time I shoot my probe, I will start at 0, 0. And I also have a list for my temporary y heights. This list will mean that I will store the height which I am reaching with my current velocity for every height actually. But I will only calculate or get the maximum y heights only if that velocity will land on the target, will make the probe land on the target. So if the velocity will not make the probe land on the target, I will just ignore this temporary heights. So I have a while loop, and as long as my x point is less than my maximum x range, which will be the ending x point, as long as I will not cross it, and my y point is larger or equals to my starting y index, because it is a negative, it's on downward. So I have to be higher than my ending y point. I should not go over it for my while loop to work. So if my y point, if my current y point is higher than my maximum y height, which is initially 0, I will append that y point to my temporary heights. And this is when I'm in the range. So if I have landed on my target, which means my y is in this range, 0 and 1 indexes of my y range, and if my x point is also in that range, I will append my velocity to my matching velocities. And only if my velocities cause the probe to be in this range, then I will check if my temporary y height is not empty, like that I have actually exceeded my previous height. And only if it's not empty, I will get the maximum of those and assign it to my maximum y height. This will be the y height which my velocities, my correct velocity, let's say, correct velocities which will make the probe land on its target. So then I will break my while loop, because I have reached my target. Otherwise, I will update my coordinates. So I will update my x point with my by my x velocity, my y point by my y velocity, and then I update my velocities. If my x is higher than 0, I will decrement it by 1. If it's 0, it will stay at 0, because in one example, like I saw that even if x doesn't move forward, y keeps going downward. Like x can stay at the same point if it has reached 0, and y can keep going downward. So my y velocity will always be going downward. So at the end, I'm printing my maximum y height. I started my loop with smaller range. It was 50-50 before, so I checked in different ranges, and it didn't take that long. So I kept the 100, because after I reach a certain number, for example, if I start at 10, it was changing, right? So 45, it's not even changing at 10. Say 5. After it reaches a certain range, it stops to change. So here it's 45. Even in the 100 range, it's 45. So that's the maximum y height that one of the velocities can reach. I'm also keeping track of the proper velocities, the ones which cause my probe land on the target. Yeah, this is part 1.
Cool. So you're just you're basically iterating through all the possibilities of x and y,
Yeah.
firing your cannon.
Yeah, so I'm starting to shoot like every direction one by one, shooting. Yeah.
Well.
Yeah. Let's go through the target area. Okay. Cool.
Just raising it up every time.
Yeah.
The Y's go.
Yeah.
And yeah, the Y's
kept
go.
going up, so boom, 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 boom,
Yeah.
boom, 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 boom.
The Y's to the X's. So it starts out with like 0, 0 and 0, 1.
Yeah, actually both of them like one by one. Yeah.
Yeah.
Every direction I'm checking every speed.
Yeah.
Okay.
Cool.
I'll share mine and show you maybe a lot of that was unnecessary.
Oh, for part 2 it was, wasn't it?
Yeah, so part 1 on this one, there was a lot of stuff you didn't need to do. because essentially y and x are independent of each other. The initial x velocity is the only thing that matters for the x value. The y does not affect the x velocity at all. Likewise, the x does not affect the y velocity at all. So that means the y doesn't affect the x. Well, x doesn't really affect the y position at all. So what I initially did is I calculated what I needed for my x velocity, or pretty much what x velocities were possible without going off the edge of the map. But I essentially didn't even need to do that, so I commented it out. So what I ended up with is I just typed in my input here because it was so short. I didn't need to import it at all. I just created my target object with my x1, y1, or x1, x2, y1, y2. So that has my target borders. And now I ignored x completely. I don't need it. I don't care about it. All I need to do is figure out what's my maximum y velocity that can land inside the target area, and then what maximum y value does that reach. So I just created a for loop here. I set my max y. I believe this one's for my velocity, which I did not make clear. Velocity, and then this one is for my maximum y position or height. So I just guessed, for some reason I started at 5,000 and went down.
Oh, a lost opportunity to use your 9s.
Oh, but I also cut it in half, because if I wanted to, it would have been twice as much. Yeah, I know. Ah! I broke my own code. I feel embarrassed now. Anyways, so I'm going to check out my current y. So is this velocity or position? I don't even know at this point.
Hopefully it's velocity and you can stay consistent with finding the y. No, but you got Vy as well.
Yeah, now I got my Vy. I think Vy is my velocity y.
And current y must be your position then.
Yeah. I got a lot of stuff. This was 2 weeks ago. I don't even remember it. And then I got another loop. What am I doing?
Oh, yeah, that is position because you're comparing
Okay.
against the target position.
Yeah. So now I got another loop inside where I'm checking my current y and I'm adding my velocity to my current y.
And you're,
So I'm adding,
Yeah.
so I'm either going up or going down based on what my current velocity is. If my current velocity is greater than 0, I'm gonna set my maximum value. So this is going to be my final answer. I'm going to set my maximum value to my current y, because that means I'm still going up. I'm not quite at the top of my arc yet. And if my current y position is greater than or equal to my target.y1, so my border here, that's the bottom of the target, and it's less than the current y, or less than target of y2, so the top of the target. So if it's within the target area, the target y values, then my maximum y is going to be equal to I. So yeah, so my maximum y is going to be equal to my current I value that I'm checking. Then I'm going to break. Because that means, I guess I'm finished. I found the maximum value, the maximum height that can get inside of the target value.
but you're out, you break out of your inner for the,
Yeah, why do I do that?
but you're still on, oh, but you still have a 51. If you found the max, then you break out of your outer one as well.
Yeah. Yeah,
So you just pass it
so
on.
if my max is greater than 0, then yeah, I can break out.
Yeah.
And then I was previously printing before my velocities, so my x velocity and y velocity, but now since I ignore my x, I can just print out my maximum y velocity and my maximum y position. So I'm going to start out with my y velocity, I guess, at 259, and that's going to get me to a final y position of 33,670. Seems quite high.
It's pretty high.
Launching it straight up. Yeah, so this one was
It's a lot of
really
gunpowder.
really easy because x and y were independent. You didn't need to care about them together.
Right. Cool.
Actually, if you keep track of the x also,
Yeah.
The second part was also easy, but since you ignored all the coordinates together, that might have been hard for your part one.
Well, I still had that code. I just commented it out after I found that it was not used. So I still did calculate an X value, but actually part two, I don't remember it, but it didn't take that much longer, I remember. But yeah, part one at least was pretty easy for this one.
Yeah. So yeah, my part one and part two vastly differ because this is my part one.
No way, I love it.
So, but before we get into this, let's get into how.
Does it split one result? This,
Huh?
this split one result?
This does everything.
Yeah.
Scratches your back and makes a copy
Because
for you.
yeah. So going off what Scott had said earlier, X's and Y's are independent, right? And essentially what happens is the rise is a very steady decay, right? It always drops by
It was
one.
incremental.
Yeah. But the falls are also incremental
Yeah. A certain point. Yeah.
to a certain point, as well as the X's, but we're, like we said, it was independent, so we're not gonna look at the X's. Now, the other thing they're gonna notice is that you're always gonna hit your plane. No matter how you fire your ball, it's always gonna end up at the plane because it's consistent. As it goes up, it's also gonna come down at the same level, right?
Yeah,
And so I can ignore the entire top half.
the 0, 0, you're always
It's
gonna hit.
gonna zero out.
Yeah.
The only thing I have to know is this initial one.
You're sharing the zeros.
What's that?
You're sharing.
Oh. Yeah, then that's probably gonna help if I actually show you what I'm looking at. So let me reshare. Okay, so, couple things.
Yeah,
First,
you're always gonna come back to that 0 plane.
you're always gonna come back to ground, especially if you're just gonna go up and take snapshots at the same rate you're gonna take snapshots as it goes down, right? And so the only thing I need to really worry about then is how fast is it going when it hits the ground? Because then after that, it's just going to go, 1+ as it goes down. So I could ignore the entire top half, but I need to know how fast it was going when it hit that plane of where I shot began. And that can be done with basically shot minus shot plus 1
Yeah.
on the negative side, right? Because it's always increasing by 1.
Right.
So I just need to
Shot plus
know what my initial Y shot was here. So for here, for example, is 1, 2, 3. So it's going to hit the plane and go 1, 2, 3, 4 plus 1.
Yeah.
Right.
So you just want that to be in the target. And you probably want it near the bottom of the target or at the bottom of the target.
Right. So you want to
get the
know
maximum velocity.
that as soon as it passes the bottom of the target, you've gone too far. That's your border, is the bottom of the target. And so, so that was my approach. And I think before we talked about this thing of how fast, something was gonna, how fast can you approximate something that increases on a constant rate? For example, +1 is a great example because we've talked about this before, and I mistakenly attributed this to Francis Bacon, but when we talked about before, adding +1 to every other number and you add it all up to get a total, what's the easiest way to do that? And one way I described it was cut the list in half, flip it on itself so everything matches up with a partner, right? And it's usually a +1 partner, especially if you're adding by 1. So a list of 1 to 100 or 0 to 100 doesn't matter. You cut it in half, you flip it over. It's 100 plus 1, 99 plus 2, 98 plus 3, 97 plus 4, and you take those and basically you take +1, you divide it and you multiply by 2, and you get essentially the entire list added up together, right? And that's actually Carl Gauss, not Francis Bacon. So apologies for those of you who are like shaking your head. Probably it was nobody, but in my mind I was like, oh, I got it wrong. But anyways, so Gauss.
All I know about Bacon is knowledge is power.
Knowledge is power, as well as the Bacon cipher was another famous thing that he had, was a substitution cipher.
I just know the common joke. Knowledge is power, Francis Bacon. And a lot of people are confused. Why is France Bacon?
Yeah.
Francis sounds like France is. Francis Bacon, France is bacon? What? It's kind of a common mishearing joke.
Sure. And so then the question is, how do I use this to get the number I want? And essentially you can use your Gauss numbers. So I have a little note here. I have to pull this away. You know what? I'll wrap it so you guys can see. Oh, you guys have to change my screen again. Honestly, I'm looking at this again with fresh eyes from a couple of weeks ago.
2 weeks at this.
Yeah. Highest trajectory regardless of x value, so that we only need the y. And for highest, we want the furthest from 0 or the lowest point on the target.
Yeah.
Right, the lowest point on the target area. And to find the lowest point on the target area, let's see what I do. Since it's first to cross the 0 line, it's 1 faster than the initial trajectory, or initial trajectory was 1 less. Gravity reduces 1 by each step until 0. So adding them all up is like Gauss's control number sum. So I have the Gauss formula on 5. Essentially, you take the number and divide it by 2, and then multiply it by the number of factors there are, and that gets you your height.
Yeah. I like that essentially you made like a 4-line answer for this one.
Yeah. Mathed it.
Yeah. Yeah, it's a lot of clever shortcuts that you noticed there.
And there'd be other problems where I didn't notice a clever shortcut and I suffered greatly. So I'm glad I at least got one.
Well done on this one. I applaud you.
All right, so part B, let's move on to part B. Part B was a little bit more complex, and I had to rewrite to actually do the problem as probably was intended.
Part B, we had to find every different combination of velocities, X and Y velocities, that will get you into the target area.
Yeah.
And we have to get the total number of possible shots.
Right. So this is a little bit more iterative. I didn't think of anything clever on this one, so I actually just brute forced it, as far as I remember at least. But I still use Gauss, so I don't use the upper halves. I only use the lower halves.
Much more lines here.
Yeah, a lot more lines here, right? So, like, up to here, that was my last program, but now I have all these other lines.
Now you actually need the full input. I like that you ignored 3/4 of the input for the last one. You're like, I just need that minimum Y.
Yeah, I just need the Y. I'm going for it. So this one we have to consider X. So I do X, and looks like for X, I also used a Gaussian because X also decays by 1, and so that was kind of convenient. And so I use that to get the lowest X, it looks like, the lowest possible X, as well as the maximum X. I'm not sure what I was thinking, so I can't exactly explain what I'm looking at. So I get a number using the Gaussian generator, starting with 1. So 1 is just 1, and then 2 should be 3, and 3 is 4, and so on. And so I'm getting I'm adding up all of those Y to get the lowest X and the highest X. I don't know, I'll have to think about this one. Maybe I'll come back to this one. And then for the Y, it looks like I'm looping from all my lowest X's, the lowest possible X's to the highest possible X's. So I'm using X to constrain my search, because I know my X is going to decay to be only within a certain area. And I don't have to, because Y's, like the Y's, you can go really far and it'll just drop straight down through the area. So I was at least going to constrain to 1, and I constrain to X's first. And so within those X constraints of possible X values, now I'm looking at possible Y values. And it looks like I'm just looping through all the different possible angles and seeing whether or not it goes through that area. But I think, being able to at least reduce one of the two dimensions, X or Y, into a certain area saves me enough time to be able to generate the answer in acceptable realms. And it looks like even for Y, same thing as before, I'm just making sure that we don't, as soon as you shoot beyond the target, okay, we're done with this one. And then break out of that inner loop of trying all the angles at a particular X. Then I go to another X value, then try all the Ys on that one until I miss. And then as soon as I miss, I try another one, and so on and so forth.
Cool.
Just be my answer. Any questions so far?
No.
Okay. All right, let's go next.
I can go since mine is much shorter, not much change. So I was already storing my velocities in this matching velocities array, every velocity which will make the probe land on its target. So for this one, I just need to return the length. And also in the part one, I was just shooting the upward. And for this one, I'm just starting at -100 or 200 range. It will give me
How'd you get those ranges?
just random.
Okay.
Because once you reach a certain range, the length of your matching velocities stops increasing, like it will not change anymore. So then you realize that any speed or any direction higher than that range will not land on the trench anymore. So 941, right? So even if I make it 300 from here or higher, you return the same length of the velocities. Oh, I think this is the correct answer. 1000. So if we go to 400 now.
What's it doing?
Yeah, it will return the same length. So we can stick with 300 range. Yeah, and it played really well that I was storing the matching velocities in part one actually. So I just needed to update the range, shooting range. So
Cool.
and also, yeah, one more thing is I am this range thing is exclusive, so it doesn't include the ending point. So I had to increment my targets by 1, my ending targets by 1. So I think it was 30, and this one was -5. So I had to increment this one to 31 and -4. So this thing is exclusive. So basically shooting again.
Yeah. But this time storing all your results and then, pulling from your results. Right?
Yeah, I think you had a much more better approach with constraints. Maybe I could also constrain this one to getting my X points first and then check my Ys, rather than having the entire range.
Well, your final answer was a lot smaller than mine too. Mine was closer to 5,000.
Mine was 1000.
My final answer was 4,900 something. I had a lot more possibilities than you.
Let me check.
You know what yours was, Alex?
Mine was 1994. Can you let me know your targets, Scott?
Yeah. Let me check. My target was X was 25 to 67.
25
minus 260 to minus 200.
260.
Yeah, to 200.
Like this.
Minus 260, minus 200, 25, 67. Let me double check. 25, 67. Yeah, it's like that.
So its increment is by 1 and 199. I think to have a maybe yours will have a wide range.
Yep, that's the right answer.
You're gonna have the same input set.
We do again. Interesting.
Oh, Alex, you're saying this, Scott?
Yeah, it's 4903.
That's interesting. I wondered when I saw 260 minus 260 for your minimum Y in your part 1.
Alright.
So I thought, hey, that looks familiar.
Okay, so that's it for me.
All right, well done. This one felt easier than quite a few previous ones, I think, for me at least. Like 15 and 16 took me a long time. I felt like 17 was like a sigh of relief.
Yeah, well, it was brute forcible.
Yeah. Yeah, yeah. Let me share my part 2. I don't think I shared it yet.
Okay.
So for this one, yeah, I kept a lot of the same code. I have my target the same way where I just typed it in. I had my minimum X that I was calculating from my part 1 that I had commented out. I just uncommented it for this one. So I'm finding the minimum possible X value.
Hey, the 9s.
Yeah, I'll organize that for you. And I also know that my maximum X value can't be greater than the far edge of the target. That means it would just shoot and go past the target on the very first snapshot. So that's going to be my max X. I'm going to just use these as my constraints and then do similar to what Farouk did. So I got my max X and my min X. And I know my minimum Y would be if I'm just shooting pretty much straight down and I go past the bottom of the target area. So that's going to be my minimum Y. I can't be deeper than the deepest edge of the target. And my maximum Y is just my same code from part 1. So now I just have a little bit extra code here where I'm finding my options. So I have an options array. And so this is just the possibilities, possible combinations of Y and X velocities. So I pretty much just loop through from my minimum X to my maximum X and from my minimum Y to my maximum Y. And then I just do all of the shots and calculate the position after every step, essentially, in each shot. I'll add to the velocity, I'll add to the position based on the current velocity and subtract from the velocity, and eventually end up with a giant array of options. There will be all of my possible X and Y values. And I'm adding it in like this, so just with my I value, comma, my J value. And then all I need to do for my answer is to just show the length of that options array. And it runs nice and quick. If I do it here, boom, get the result almost instantly. So yeah, this one wasn't really very difficult, I thought. I liked it. It was, yeah, breath of fresh air after all the pain that I've felt on 15 and 16. And in the future now with 19 kicking my butt.
I actually remember watching that conference by the Eric Wassel, the founder, and he actually mentions this, giving consequently harder problems might disappoint the user. So he accepts that we'll put one easy or one or two easier questions when the problems level gets too difficult. And I think you can see this, right? We
kind of boost your confidence.
Yeah.
You start to get depressed and then you're like, oh, I know how to do this one. So you feel good again and get like
we get a few easy questions once in a while. I think that's good too.
Yeah, okay. I didn't know. That's clever. But yeah, I feel like this was definitely easier than some of the surrounding ones. I feel like 18 was another difficult one. That was the snailfish math, I think.
I didn't solve it yet, man. Do not say those words.
It was mentally draining to think about before I even started, but once I actually got started, it went well. It went smoothly.
Okay, good.
I think that one, just start plugging away at it. Just start writing code, and you can get there.
I remember when I go to dentist like, I will pull your teeth now. It will hurt. I want to say like it's not hurting. Go on. Like he's like it will hurt, and it makes me scared at his words. You know.
And you're like, I'm not in pain, so he tries harder to make you hurt.
Yeah, that's not pain. Again.
Dig that floss in deeper into your gums.
I think it's better if they do not say like it will hurt. If it's hurt, it will hurt. What? How can you help by saying it?
I think for some people, like it sets a level of expectation. It does it for me.
Yeah.
So when they tell me, oh, this is gonna hurt a little bit, they actually, it's to at least get you ready mentally so that when it happens, hopefully your expectations won't be met by the pain, and then you'll consider it a not unpleasant experience.
Yeah. it's
Whether you're just
bearable.
gonna go in and be like, oh, you won't feel a thing, and then you're like,
You start screaming.
yeah, and then it's his fault.
Maybe
So,
that's a good thing for.
There's some psychology, I think, in there. I do the same thing with the intensive students. I let them know it's gonna be intense, so that they're mentally ready for it to be intense, and they're not like, you didn't tell me it was gonna be this
Well,
hard.
they should know, but instead of the students
You
who
would think
didn't even
so.
do homework and didn't
Yeah.
try.
But yeah,
Yeah.
anyway, cool.
Okay.
16 and 17 done.
16, 17 down, and we will do 18 and 19 on Friday.
You guys done with 18 and 19?
No.
Alex is. I'm done with 18 and part of
They'll be
19.
done with 19 by Friday.
19 I've been working on for like an entire week. And
He'll get it. Have confidence. How are you going on those, Ferg?
Me?
Yeah, you're working on 18. Have you started?
I did
19?
not.
Oh, you
I
haven't
did not
started?
start.
Okay.
I think. Let me check. Let me check. I think.
well, you still gotta finish 16 part 2 now. But you've seen our answers.
Yeah.
If you want.
I think 16 part 2 worked on me. I
Okay.
submitted. 18. I have a like template written, but nothing. So I tried. I think something, but.
I would
nothing.
say do 19 part A and then go back and try to do all of 18. 19A is not too bad. You can brute force 19A. 18 is just a lot of tedious.
I remember it's snailfish man's
Parsing.
homework. Snailfish man's homework, right?
For me, I remember 18 actually not being that bad once I started.
Oh, yeah, okay.
I remember not wanting to start it because I thought that it would be very difficult.
Yeah.
But once I started going and creating functions to do everything that I wanted, I remember it not being really that hard.
Yeah.
And I think I did enough for part 1 that part 2 really wasn't much extra.
Hmm.
I don't even remember what part 2 was because part 1 was so much.
Yeah, that's my attitude towards 22. I know what to do. I just don't want to do it. This whole three dimension things and like dividing or pulling volumes out. It just
Oh, yeah, part 2 actually messed with me for a little while. I spent a while on day 18 part 2, I remember.
22 part 2. Yeah.
Well, 22 part 2, but yeah, day 18 part 2
Oh,
also.
18 part 2 as well.
I had forgotten what part 2 was, but now that I'm looking at it, I remember it took me a while. I don't know why it took me so long. Like, I think I was just confused by the question.
Mm. All right. Well, I'll see you guys on Friday. Lots to get done between now and then.
We're having fun still, right? It's
Yeah.
fun. It's fun.
Yeah,
It's
of course.
Is it fun?
All right. Bye.